What's up, Cougar Nation? It's Tuesday, April 7th, and we are going to talk about AMI Day 12, and we are talking about transformations. In this question, they are asking you to describe a transformation that goes from triangle 1 to triangle 2, and then in the second question, triangle 1 to triangle 3. And so, as you can see, we've kind of broken down the answers into a little bit more manageable work. First thing they're going to ask you is, what is the rigid transformation that's represented here? So the first thing you have to ask is, well, what is a rigid transformation? A rigid transformation is any transformation that keeps same shape and same size. In other words, the pre-image and the image are congruent. And so for us, the choices for a rigid transformation would either be a translation, a reflection, or a rotation, which is down here in your vocabulary word bank. So let's look at those. I'm going to be using a website called GeoGebra, and I've already put a triangle in here. And so let's first begin with looking at what does a translation look like. And so we're going to translate this triangle, and let's go over to and down to, and now we can look at what happened. Notice that orientation, A to B to C, A to B to C, they're both clockwise, so orientation stays the same. Translation, we have the same shape, same size, and the corresponding angles are congruent. So that's a translation. If we move back and let's go ahead and let's rotate. So let's take this triangle and let's rotate it. We're going to rotate this around that point, and let's do a 90-degree counterclockwise rotation. And so as you can see, same shape, same size. As I look at the orientation, A to B to C is clockwise, A prime to B prime to C prime is clockwise. And then if we look at our third transformation, we're going to reflect. And so let's build us a line, and let's reflect over the x-axis. And so we're going to reflect over a line. Here's our triangle, and here's our line, and there we see the reflection. So what do you notice? Same shape, same size, but what's different is the orientation. As I go from A to B to C, then we are headed clockwise. But as we look at our image, it's going A to B to C, it's going counterclockwise. So the orientation changes. So as we look at our problem, as I'm looking going from 1 to 2, consider, does the orientation change? As we slide, does it look like a slide to you? Does it look like a flip to you? Or does it look like a rotation to you? Remember, if I'm trying to pick between a reflection and a rotation, then I want to look at the orientation. Hope this video helps you guys, and please don't hesitate to ask us questions. One more thing before we get out of here, as I look at corresponds, so let's just look back at this GeoGebra we were doing here. Let's get rid of all my pen marks. And so as we look at corresponding, as I look at corresponding, obviously angle A, this angle is going to correspond with A prime, and they're going to be congruent. Angle C and angle C prime are going to be congruent. And so hopefully that gives you an idea what we mean by corresponds. So hopefully this helps. Guys, we miss you. We hope you're all doing well, and please don't hesitate to ask questions.